see one back there. I know somebody who wants to buy a couple.
There should be close to it.
I didn't know there was still some left. I might be well interested in a couple.
Yeah, we have a bunch of tough books that were donated. They're for sale as is for what was the rate for tough books?
It was 50. None of the ones that are here, one of them has a good touch screen. The rest appear to all be fine with bad touch screens.
All for sale though.
1, 2, 3.
There's a couple that are kind of smashed. There's one with the smashed LCD and one with the bad back.
Okay. It looks like we have one with a touch screen that was going to be safe for raffle, which we can't have because we can't gamble.
Oh, really?
6 with bad touch screens and 2 that are pretty much cracked.
All right, so 6 and 2, yeah, it's $400 right there. Not that we need funds or anything, because we're kind of sitting pretty at the moment. Yeah, Pharrell.
Yes, sir.
Pharrell.
I apologize. That being said, there's 5 more on the shelf.
Just
I don't know their stats.
keep that number in your head.
There's sticky notes on the bottom.
How many were there again?
There were 4 without touch screens, 1
Okay.
with a touch screen, 2 that look like crap, and I just saw 4 more on the shelf. And Chris said to look at the sticky notes on the bottom.
Should take one hanging on the wall.
Okay, so we have like 10 or 12 then.
Ellie.
Cool.
He's up for grabs.
Yeah, that's what they're up there.
Yeah, it's
Bring the box back here.
Next order of business, CCDC is coming quick. We still need a team, basically.
One says bad backlight, one says smashed touch screen, and the others honestly don't look bad. So the one with the smashed touch screen is that one. So the other 2 I thought were bad aren't bad.
Okay,
So
cool.
we have more, and they're right here. You're all welcome to go see them. Someone check them out or whatever.
All right, cool.
How much are they selling for?
$50, as is. No hard drive.
ID.
Power adapter. You might have to buy a new battery, something like that. But you know, you can get out the door for $150. One of those.
ID hard.
Like I was saying, CCDC is coming up quick. We still don't have a team. We need 8 people. CCDC. Yes. Apparently it's going to be here. Tomorrow or 5 minutes from now it might be there. I don't know. But yeah, if you're good at Linux, Windows, Unix, Cisco, well, Unix.
What if you're just average with all of them?
That is acceptable. You can mount a flash drive and command line. Welcome aboard. So, yeah. What?
Are you participating or are you coming as an advisor?
I'll participate. Add another piece of paper to my wall. I have a collection. Yeah, so if you're interested, get a hold of either me or Denise. I'm kind of putting my foot down. We're picking a team by next Tuesday. It will be set in stone. So if you are interested, get a hold of either myself or Denise. Next thing, hoo-ha. You wanted to talk about the cabinet.
Mm-hmm. Crap, that quickly?
Yes.
No one wants to go before me?
I have one more thing to say about CCDC. Because we're not going anywhere. I'd like to have some sort of unofficial get-together.
I'll talk to you afterwards about that. There is something in the works.
Okay.
That isn't for public consumption. That isn't for public consumption. Wink, wink.
What is it for? Just the pizza that's going?
Yeah, hoo-ha. Cabinet.
Alright. You want to finish where I started?
Yeah, sure.
Try not to knock your screws everywhere.
Just remember in my garage when we tried to make one of them with a screwdriver and a hammer.
And it failed.
So, we decided to build a custom computer, like a gaming computer, over in Laura's room. And it's evolved when we got the the clear case, it evolved into, you know, build a flashy gaming computer. Then when we realized nothing fit in the clear case, I walked by the trophy case, was holding this, and I looked at the case, and I looked at this, and I looked at the case. I realized we could just mount it in the trophy case with all the components showing and actually light the trophies with the computer itself, because it's going to have 2 cold cathode ray tubes, sound activated or just on, either way, liquid cooling. It's got a 120 millimeter radiator sitting over in Laura's room, and it's got a pretty decent sized pump for it. But what I'd like to do is mount this in the very bottom and hide the pump behind it, and use this actual piece of plexiglass to actually mount it in there, and then hide all the little fans and annoying bits towards the back of it, and see if we can get the actual maintenance to do a power drop in the little alcove right outside Laura's room. But it would still allow us to have trophies and plaques and anything, you know, we want as a group, and still have an awesome computer, and also display advertisements for the club, for the curriculum, for the school, via a monitor that we're going to put inside the case as well. That's going to run a continuous video loop with speakers.
You
No.
take the monitor case apart from the sound.
I don't feel like killing myself with that kind of voltage. I've already zapped myself like 6 times in the back room. But yeah, that's about it. Any questions on this? Anybody want to help with the project?
I'll help.
I'm sure we need network cables too.
When are we going to be working on it?
As soon as that gets refinished, they're gonna redo the base and the inside of it, but I gotta give like dimensions for mounting this and the holes we need to drill for the tubes, and then we need a there's a camera isn't there? And then we need a I think we need an 80 millimeter or a 20 millimeter hole to mount the actual radiator to the back, and it'd be nice to not have that showing and actually have it outside the case itself, so we can keep the entire machine cool. But other than that,
Here, take your devil cable back. One end done.
you don't like your fabulous cable?
No, I hate your craptastic tools. You don't even have a decent wire stripper.
Yeah, we need better strippers.
All right, so the topic of this evening is not strictly computing or computers, but on a small scale, 8-bit computing. Talking about microcontrollers here, and we have a wide assortment of microcontrollers here. Did you bring one? Or?
I brought one, yeah.
Chris brought one. Different varieties, overwhelming majority Arduino. But yeah, we're going to talk hardware, software, and applications thereof. Chad, come on, join the conversation, man.
Well, you started out fantastic.
Well, I don't know all that much from a hardware standpoint.
So you want me to describe? Well, basically, the Arduino, what you normally see in store and what you normally can buy is a complete chip form factor complete with serial USB controller on board, the actual programmable controller itself, and
He's walking around.
I was looking for a good place to start. Passing the thing around.
Yeah.
And everything on that board is actually able to be purchased separately. You can buy the microcontroller chip itself and mount it into your own circuit. What we have and what's being passed around, what Justin has up here, are actually prototyping models. They're made just to flash 1,000 times and try millions of different combinations.
Yeah. The model he's passing around is it's basically the same as let's see, show the folks on YouTube. You know, for
Let me
the
zoom
week
in.
that they didn't have video last week and complained. Hi, Anthony. That chip that's going around is basically the same thing as this big proto shield thing here. This is just oscillating LEDs, all 12 of them back and forth, and the speed is controlled by a little trimmer pot here. Crank it up, and it can go as fast as, well, faster than your eye can see, or it can go up to 1 second delay between lighting LEDs. Yeah, chat projects. What you can do with it.
What you can do
What
with
have you done with it?
What have I done with it?
Yeah,
Practically nothing.
practically none. Wow.
No. I have done many experiments and many attempts at things, but I've never actually succeeded in one yet. But I have been dreaming big. I have done Wi-Fi projects where I've tried to connect it up to my wireless router and control my computer as a remote input. I have tried to do Bluetooth adapting to my phone just to connect it. I couldn't even get it. I have tried to. What are little projects? I have tried to do just light shows like that. But with about 10 times more LEDs and multiplexing, internal multiplexing. You can obviously use a chip to multiplex externally. However, it will do internal multiplexing for you.
And you can do all that in code. That's what makes this so powerful. I mean, in the old days, to do something like that, you'd have a bunch of switches lined up, or whatever, push buttons, whatever, and you just push them all sequentially, or switch them sequentially, and that's energy spent. But this thing, you can just say every half second or something like that, switch this LED off and put that one on. It's very powerful. Then the next step up from this Uno shield here, I might want to move the camera to this. I have in this thing, controlling the effects processor for my guitar, an Arduino Mega 2560, I think it is. It has like 54 I/O ports on it, and does a fairly good job. I mean, this thing in its OEM state burned up 2 weeks ago in a power surge, so I thought, oh, what the hell, I'll just go to SparkFun, get myself an Arduino, and build my own, and it's worked out pretty well. So, yeah. What else?
Shields.
Shields. Yeah, you can buy add-on shields for these, containing Bluetooth receivers, SD cards, Ethernet. You can get the XB, which is Wi-Fi, and that thing's pretty cool.
Wi-Fi to
I played
Wi-Fi.
around with one of those.
Transmitter receiver pairs, yeah. The shields, everything that the shields, well, most of the things that you can buy the shields for, like Bluetooth, Wi-Fi, networking, that kind of thing, it'll actually do internally. The trick is, though, is these add-on shields that you put on top of them, most of them have their own internal memory, and that way they do all their own computing, they do all their own, and basically it's just interfacing with your chip. It's saying, go to this, and you do its job.
And all you have to do is plug it in. It's that simple. The code for most Arduinos is open source. You know, we like that around here. For the Arduino, at least, it's C-based. For the basic stamp, it's basic-based. What's the Texas Instruments one based on?
The program's in C, I think.
In C, cool. Is the structure similar to that of the Arduino?
I have no idea.
That would be cool if it was. Alright, so any questions thus far? anyone.
They had a
I'm getting deer in the headlights here.
Arduino powered RC plane at DEF CON this year that could actually go into like it would circle if it found a hotspot and actually geocache it.
Oh, cool.
That's pretty cool.
Oh, I've seen
Which was totally my idea and they stole it.
I've seen EF meters.
Yeah. You can actually take. I think mine's even compatible with it. You can actually make your own spectrum analyzer. Very small one, but you can make a spectrum analyzer with that thing. So for $30 and a bunch of your own time, you can save about 49 grand.
Easily.
Yeah.
Yeah, and you can find out more about the Arduino at arduino.cc. That's ADRUIDNO.cc. HIJKLMNOP. That's just weird to spell out loud.
See that papers here.
So, yeah. No questions.
I have here 34 pages. 30
code example.
Okay. 34-page example. Oh, not example, but 34 pages off the Arduino website of everything that most of their controllers can do internally. And we have stumbled upon a few, but obviously this is 34 pages worth. I have went through and kind of highlighted a few of the sweet ones, but obviously LEDs, it will control multicolor LEDs with one pin using serial. You can do camera controlling with this. 7-segment displays, multi-segment displays, LCD controllers. I have an LCD laying over there. OLEDs, video output. You can actually have composite video output. Infrared remote controlling, motor controlling. A lot of them. There is a few models that actually have built-on motor controllers, and all you have to do is say run in one direction and run in a different direction, and it will output. Steppers included. For that reason, you can say robot kits in general. I mean, you can make your own
RC plane that sniffs Wi-Fi.
GPS location.
Yeah.
Light sensors, microphones. You can do audio measurement, switches, encoders. I mean, I'm only halfway through the thing. Joysticks, gamepads. You can hook up a PS2 mouse, keyboards, capacitive sensing, touchscreens.
Import Skynet.
Self-aware.
Magnetic cards. Somebody give me your credit card. I can get your all your information off of it. I didn't say that too loud. Position sensing, pressure sensors, distance sensing, all internally. Now, obviously, you can buy shields, like I was saying, and get an add-on card, plug it in, and ready to go. But it'll do it internally. Humidity, temperature. Hold these, please. RFID, barcode scanning, barcode decoding, compass location, GPS location, accelerometers, gyros.
We'll take the dog out.
I'm sure you can make one.
If you have the know-how, the money, and the patience.
Analog digital converters, digital analog converters. That's another thing not mentioned. Every single chip has not only digital in and outputs, inputs and outputs, but it also has analog inputs and outputs.
Mm-hmm. Yeah, both of these projects up here have analog and digital inputs on them.
You can control it off a USB memory stick.
That's pretty cool.
Serial communication, SPI communication, PWM,
Pulse width modulation.
PS2, HDMI, Ethernet, Wi-Fi.
HIJKLMNOP.
Exactly. Pretty much you think these things can do it.
Yeah.
Now, there is many competitors, obviously, for microcontrollers in general. However, the Arduino is all open source. Justin can tell you more about that, but anything
right.
you think of? you're fine.
So this is the code for this little light thing, if you haven't seen it yet. It's just cycling back and forth through these LEDs. And its rate is controlled by a trimmer pot potentiometer. It's just a variable resistor. Basically what's going on here is pins 2 through 15 are put in a pin mode. Now the structure of the code, you always have a void setup, brackets, and then a void loop, brackets. Setup, that's what it does when it's first turned on or reset or something like that. It's just setting all of the static information for the rest of the program. And then void loop, it's running through that at about let's see, the one on the table there, it's running through it about 8 million times a second when the pot is cranked all the way up. 8 megahertz processor. Yeah, and you just plug in what you want it to be static and then what you want it to do while it's running. And in this case, it's just cycling through LEDs. It's going forwards, backwards, rinse, lather, repeat. You know, and this is a very simple program. Every single pin has a digital pin associated with it, and every time it runs through this little for logic here, it reads the value that's being output by the pot there, or being read by the pot on analog pin 0. This is a very simple example of the code. Now it gets a ton more hairy. I mean, it gets a ton more sophisticated. Like for that pedal board I have up here, the code is, well, let's see, how many lines long is it? 227 lines. I'm not going to go into how this works. If you want to know how this works piece by piece, you'll have to go to HackersRUs, hackersr.us, basically. I have a full 5-page write-up on there on how all this works, but yeah, commenting really will save your ass. So any questions about the code? No?
What is the code?
C, basic, well, C, C++, there's some object-oriented stuff in there.
See, when you work with a projector like that, when you're old like me back here, it's hard to see that fonts, all of them.
Oh,
You
sorry.
just blow it up just a tad.
Sorry about that.
You can do that, Mike.
Well, let's see if I can do that.
I bet you if you cranked it to like 150 or something. Yeah, there we go.
How about that?
Yeah, that was a little easier to read. Okay. See, I've never taken C.
Can you go full screen on that now?
VB.
What? No, that's inside of the editor. That's just blowing it up. But yeah, there are some functional and there are some object-oriented parts in this. Arrays are ridiculously easy to work with in the Arduino hybrid language. Much easier than C, I found. So, yeah, any other questions? No? Anybody want to say anything else about the controllers they brought?
I wish I knew more about them.
Okay.
I know that the Texas Instrument one, that uses a lot less power to power your electronics than the Arduino. Huh?
We don't have to pay a 5 volt or 3
Well, USB operates at 5 volts, and I have it plugged into the USB port right here. I don't have a 9-volt adapter for it yet. As a matter of fact, pedal board I'm going to run off of phantom power through the MIDI cable. Yeah, what one do you have again?
I've got the same one he's got.
You got the same one. Alright, and what are you done with it?
So far I made the blinking orange lights of it. That's about it. Which is the demo application it came with, so we went through the steps there to actually program it out.
Alright, cool. Keep us updated. Well, that's pretty much all I have prepared for this presentation. If you want to hang out and take a look at some of the projects up here closer, go right ahead. And yeah, if there's no other business to handle here, any other business? No? No business. Wow. That's a quick meeting. Well, class dismissed.
Ken was going to join us, but he, I think, either had family or girlfriend stuff. So
Ken?
or ours.
Oh, okay.
He wants to literally join the group. Which
Oh, cool. Well, bring him in.
I find it funny that a subject this big got done in that quick.
Well, it's also a little.
Yeah, I know.
What about some of the functions that you use, digital write?
Yeah, okay, so some of the functions, this is built in. Pin mode, this just assigns what a specific pin does. In this specific function here, or in this for logic, it's going from pin 34 to pin 43, and basically assigning the pin as output. That's the LEDs that are on this pedal board here. And then digital write high, so they float high, as in at 5 volts. There's 5 volts applied to them at all times. It makes them go out through the pin. And when I want to turn an LED on, I make it low, which then it would be 0 volts going to the pin, which grounds it, turns it on. Yeah, what else is in here?
And you can find these functions on the website.
Well,
How to use them, right?
Everything is open
on their
source.
wiki.
Basically you can go to the website, you can go to forums, you can find examples of what you're trying to do, and usually copy the code and just slightly alter it to what your specific application is. The Arduino, with the Arduinos, everything is purchased and open source. It is protected by a license code, but the only thing.
There you go. Every single built-in function, logical operators, everything. It's very well documented. The IDE is free. Go to download. They have it for everything. The 64-bit Linux, they have an older version for. They haven't caught up on yet. Getting started guide. The hardware. Hey, there's my Uno. There's the Nano. There's the giant ass thing that's in the pedal board. Yeah, Arduino.cc for more information on that.
Now, can you take the processor out of the?
Out of this one, yes.
And
Out
then
of the
use it.
Mega, no.
Okay.
Mega is soldered in. It's really tiny and has like hair-like wires on it. Mm-hmm.
ARE.
Oh, okay.
Whereas this is just a chip with a socket.
Yeah. And there's very little supporting hardware that needs to operate against it.
Yeah. Yeah, Chad was nice enough to give me this LCD screen to play around with.
It's like a little TI the only offboard hardware that needs to work is board regulation.
on site. And Chad's a contributor now. And,
Not yet.
Not yet, yeah. I did go into excruciating detail in describing what everything does here. So if you need more information, hackers are us.